Okay. Welcome everybody to another SIG scheduling meeting. Today is September 7th. As you all know, this meeting is recorded. So please be sure not to share anything that you don't want to share, and please adhere to the CNCF Code of Conduct. We have two items in the agenda. The first one is by Kathy. A CAP proposal for a generic scalar cache extension. Is Kathy here? I think I see her.
Oh, I'm here.
All right. Yeah, take it away. Do you need to share your screen?
Hey, are you talking to me?
Yes. Do you need to share your screen?
Yes, I can share the screen. Okay.
Okay.
So you want me to proceed now?
Yes. You should be able to do that now.
Okay, sounds good. Let me share my screen. Hold on a second. Okay. Yeah, here. Okay. Share. Can you see my screen?
Not yet. Still black.
It's loading. Okay.
Okay.
It's
yes.
good now.
Okay, good. So I'm going. It will be short. So I'm going to go through the generic scheduler cache extension for the scheduler plugin and why we need to do this. Okay, first, so the motivations. We found out that for each auto tree scheduler plugin, that plugin needs to save some store some resources right in the cache, and then. And especially if those resources involve some complicated specification and accounting models, and then each plugin has to develop a local cache for that. And also, in addition to develop that local cache, it also involves implement independent, informal, and also event handling logic to replicate. I mean, every scheduler plugin has to implement that, which is a duplicated effort. And also, there's also another problem: the resource data, because there are two caches, right? One is the core cache by the Kubernetes scheduler, the core scheduler. Another is the cache by each auto tree scheduler plugin. And then, if sometimes the resource data fetched, between the two time points as identified in the slide in the diagram on the right. So at the T1 time point at T1, and by the core scheduler cache, and also could there be another time point at T2, because these are different flow, different process. Then if these two times may be different, then the data fetched will be inconsistent, will be not the same at the same time point. Then they could be inconsistent, which could lead some scheduling problem or some preemption problem. So this is two issues.
Hold on for a second. So by inconsistent, so basically the inconsistency can happen even within the in-tree schedule plugin. That is why in the beginning of every scheduling cycle, we do a snapshot. So I'm not fully understanding that, because the inconsistency, it's not recommended for you to, by any time of your scheduling cycle, you go to the cache to fetch the latest fresh data. That is not recommended, because we know this kind of inconsistency can happen. That is why we snapshot in the beginning. And for out-of-tree plugins, if you use some CR objects, we will also recommend to do a snapshot on the CR resources, and then use that as a source of truth during this cycle. And then go to the next cycle, you can do another snapshot.
So, okay. Yeah. I think that makes sense. Yeah, we understand that it could also happen, for even without this auto tree. But still, I think if we can have one extended cache together, extend the current scheduler cache, this will reduce the inconsistency probability, reduce that. But the key point is not that. The key point is, each scheduler plugin has to re-implement the, a local cache and also the event handling logic.
Yeah. Okay.
Thanks for that, comment. So the reason, we met this because when we try to develop a DSIO aware scheduling, and we found out that, we have to do this, we have to develop a cache to store all these data. Yeah, I think this is just an example of that. We have to, re-implement this watch logic, re-implement the informer, and then we find out that inconsistency, problem. So I will hand it over to Teresa to go through, our proposal, brief go through our proposal.
One second. Can you actually expand more on the use case? Like
Oh.
what kind of informers do you use? If you use CRDs or not? Because before we do any significant refactoring, we would look at the use case, whether the use case makes sense,
Okay.
to make sure that the investment is worth the complexity.
Okay. So for the maybe Teresa can talk a lot more detail on that. The use case is for the DSIO. So currently in Kubernetes, we know that we have CPU memory aware scheduling, maybe some large page and some storage. But we do not have DSIO aware scheduling and isolation. We do not have network I/O. We also don't have any cache or any memory bandwidth aware scheduling and isolation. So we're thinking about to add those functionality to fill that gap. So when we develop the DSIO aware scheduling, and we just like follow the AutoTree scheduler plugin, we have to develop to implement our own cache. So that to duplicate the logic. Does that make sense?
Um,
The DSIO scheduling, DSIO is another resource. We got this requirement from customers saying, they have noisy neighbor problem because there's no DSIO aware scheduling and isolation, and the workloads scheduled onto the same node would compete for the DSIO resources, and then those workloads service were impacted because of that noisy neighbor problem. So that's why we add this DSIO aware scheduling plugin.
And where is this information coming from? Is he storing at CD as well as a CRD, or what is the?
Yes, it's stored in the CR, and we use an informer to listen, watch the CR, and update the latest resource information from this CR. And the idea comes from that, and every scheduler plugin need to implement. Need to add an informer to watch the resource update and update the latest info to the local cache. And why don't we use one informer to take care of all of this? So that's the basic idea. Yeah.
Okay, so I have some questions. Maybe we can leave them after you go to the next slide. But one immediate question is, why does it matter? Because first of all, the informers are all shared, so it's still the same informer. And again, even if you have a single cache in the scheduler side, you can still have inconsistencies, such as you might have a pod, sorry, or I guess you care about a node, I'm not sure. Let's say you have a node for which you have a corresponding IO CR, and you could have a case with or without a shared cache where the node exists in the cache, but the CR doesn't exist, or vice versa. The CR exists and the node doesn't exist. So all of those things can still happen, even if you have a single cache. So those will be my overarching questions. Maybe once you go through the slide,
then
it may be more clear. But
as there are two cache coexist in the current implementation, I mean between the in-tree plugin and out-of-tree plugin, so there is a time interval between the time T1 and time T2 specified in the second page just now. And so I think our proposal can reduce the likelihood of the scheduling failure in that time interval. So although the probability is very low, but it's kind of we can help to reduce the probability in that time interval.
Yeah,
and
I think
also,
I think that's the key motivation, and we have to address clearly. That sounds a very significant perspective.
Not very
as Aldo said, if the inconsistency is coming from that two totally independent objects syncing issues, then even with the native sharing cache for both in-tree call API object as well as CR, then this kind of issue cannot be resolved. For example, you have a node object, you have a node related disaggregate CR, but they are not guaranteed to be always sync the status. So yeah, that is the point we have to address clearly, whether or not this can fundamentally resolve the problem.
I guess my point would be, if we are just reducing the probability, I don't think it's worth. Because we will be adding likely some complexity, and we are not even going to solve the issue. We are just reducing the probability. That to me doesn't sound like a good investment. But
I would like to come up.
Let's go through the proposal. Maybe maybe you already thought of this.
I think you are right. So we cannot, we won't, I mean, it will still exist, the inconsistency, right? Just reducing the probability is not a very strong reason. I think, the other reason is that, we would like to reduce, to increase the developer velocity, to reduce, the each developer's, just why we need to, for each scheduler plugin, we need to develop a separate cache. We need to duplicate the effort of, creating that cache, creating the event handling logic, creating the informer, implement the informer, all those.
I'm not quite understanding that, because I guess you shouldn't build a cache for objects that are already cached. Like, you shouldn't have a cache for pods, for example, or nodes. And you would only be adding event handlers and a cache for all the other objects that are not already there in the existing cache. So again, doesn't sound that valuable, or that it would reduce developer speed, for one. But I think we're maybe just like thinking too theoretically. Maybe let's just go through the proposal and
Oh, maybe Teresa can clarify what kind of additional. So you are saying there's no need to add additional resources to the local cache? Is that what you mean?
Yeah, I'm not seeing major benefits over just having your own cache for your own objects in the plugin, which it might be more, maybe a little bit more. I'm still even having a hard time thinking that is a lot of effort. But even if it is, it's complexity that doesn't affect the rest of the existing scalar code, which, yeah, it might slow down the development of the scalar as a whole, while it just optimizes for your use case of a out-of-tree plugin. So that would be my hesitation. But please go ahead through the proposal. Yeah.
It's not just optimized for our plugin, it's for all the scheduler plugin. If we have a test extension so that each schedule plugin or in the future, the new schedule plugin does not need to implement their own local cache. Yeah, but we can see, the effort and the benefit, whether it's a strong case. Yeah. Okay, Teresa, sorry, go ahead.
Okay, let me proceed with the proposal design. And the core idea behind this proposal is to add a cache extension to the current scheduler cache, which is highlighted in the red in this diagram on the right hand. And as you can see, that let's take the disk IO aware scheduling scheduler plugin as an example. The available disk IO throughput, disk IO IOPS, block size, and rewrite ratio, these attributes and their accounting method will be included in this extended cache. And at the filter hook point, the entry plugin would fetch the allocable resource and the consumpted resource from the scheduler cache, while the disk IO plugin will retrieve the disk IO available bandwidth from the extended cache. And in this case, the scheduler will take care of watching the pod and node events to update the vendor-specific resource and both resources. In that case, the out-of-tree scheduler plugin does not need to implement use another informer and maintain their own cache, and it will simplify the scheduler plugin's development. And as a result, some new interfaces and APIs are required to be are supposed to be introduced to describe the resource and customize the resource accounting methods, and also manage the life cycle of the extended resource. Cassie, would you move to the next page? Here is an reference design for our proposal. And this is a class diagram. And the class diagram illustrates the modification to existing classes and interfaces in the current scheduler, which is highlighted in blue. And the new classes or interfaces introduced by our proposal, which is highlighted in green, and some new classes that's supposed to be implemented by vendors or the scheduler plugin developers, which is highlighted in gray. So from the left hand on, the node info struct is proposed to be extended to hold the extended resource. It is a map. The map's key stands for the resource name, and the value keeps the vendor specific resource information. And the extended resource interface is an interface that manages the resource accounting method through the add pod and remove pod methods. And the scheduler plugin developers or the resource vendors can customize their resource attributes and then their accounting methods by implementing the extended resource interface. And the extended resource handle is an interface to manage the extended resource and to keep the extended resource up to date. The run method of the interface is to retrieve the resource info and initialize this resource in the extended cache. I mentioned the resource vendor here is because that it can be, in our scenario, it can be an independent role different from the scheduler plugin developer. Meaning that because the resource vendor knows best about their product, the resource vendor can define can implement the extended resource interface and the extended resource handle interface to define the resource attributes and the how the resource is accounted. And the scheduler plugin, in that case, the scheduler plugin developer can use the extended resource handle straight away without the need to know too much about how the resource is counted for making their scheduling decision. So finally, the scheduler plugin would instantiate the extended resource handle and retrieve the extended resource through this handle to get the information. So overall, I think the change to the current scheduler is very limited, but it can largely simplify the schedule plugins development. In the backup session, there is a reference implementation and a simple example to demonstrate our thoughts for reference if you have interest.
Yeah, but probably will not go into that detail. Okay.
So
Any questions?
So by extended resource, you mean CR objects, right? Not. I just wanted to be distinguished with the standard Kubernetes term extended resource, because in Kubernetes there is already a predefined name called extended resource.
Yes. It is an object stored in the node in the new data structure we introduced from our proposal. So it is different from the Kubernetes term.
Okay.
Where is the information coming from? Is it a different CR object? Or is it an annotation in the pod? Or in this case, I guess node, because it says node info, extended resource. Where is the information coming from?
Yes, the run method of the extended resource handle will take care of how take care of this, because it will retrieve the information through an CR or from a service or from other source. So it is not fixed. It depends on how the resource vendor defined it.
Yeah, so in our design, we did not limit, like, where the resource, extended resource will come from. It could come from the annotation, could come from, telemetry collected by the, by the platform and feedback into the, the real-time resource information. It could come from that too. In our case, in the disk I/O case, and also in our network I/O case and cache case, we need to collect real-time resource information, telemetry information, and do scheduling based on that information. Because it's not like a fixed value. So the information depends on other characteristics of the workload, like block size, for this I/O block size, read-write ratio, something like that. So it's not like fixed value. Yeah.
I just want maybe try my best to summarize the motivation. Maybe just correct me if I'm wrong. So you seem to want to say the requirement is that when some CR object has very close direct relationship with the objects that is cached in the in the scheduling framework, which is node pod. If like you have customer resource object that has closer relation with that, then if you define the event handler in out of a tree, then that can make it sort of inconsistent. That is why you want to add a hook to the scheduling framework so that when the node, a pod, gets updated, you can have immediately chance in one synchronizer call to update the cache. So everything for node part as well as your CR objects are always in sync. So I'm trying to summarize, but not sure if it's the real motivation that you want to introduce this to scheduling framework. Is that true?
So that's one motivation, but I think another motivation is, each scheduler plugin developer does not need to implement the event handling logic. Otherwise, we have to duplicate. If we implement like scheduler plugin for this IO and another scheduler plugin for normal IO, another one for cache, we have to re-implement all this logic. But if we can leverage the existing event handling logic in the in-tree scheduler, then we do not duplicate that logic.
Well, because separate the event handler, if there's no syncing issue, no inconsistent issue, sounds a better design comparing to have everything in the scheduling framework. Because, for example, if you have totally independent CR object, has nothing to do with node objects, doesn't need to be hooked with a node part update, I don't think that it's of a great benefits to put them all together in the scheduling framework. So my point is that this proposal should have a strong case, that is the inconsistent issues that blocks the out-of-tree plugins functionality. That is my point.
Kathy, may I add some comments for that? Yeah. Hello, can you hear me?
Yeah.
Yes.
Let me add some comments about that. Yeah. Regarding to this diagram, suppose let's assume what a general out-of-tree plugin will implement. And first, in general, if the out-of-tree scheduling plugin will handle additional resource that is exposed, it will be a disk I/O. So it will implement a local cache to save the disk I/O information. And this information may get from the CR or may get from some other metric. This is one thing the scheduling plugin needs to be implemented. Then secondly, the plugin needs to be implement an event handling mechanism, an informer, to get the notification for the node or the port change, so that if the new node added or new node deleted or the port deleted, then it can update the local cache and to update the node capacities. So this is the second thing the plugin needs to do it done. And the third thing is that the plugin needs to implement the filter or the score mechanism, like what the other plugin needs to be done. Yeah, this is the current implementation if we want to implement a scheduling plugin. But suppose in this case, and as you just said, because when we start a scheduling cycle, we want to avoid the inconsistent issues, so that before a scheduling cycle is start, we will create a snapshot. Then the snapshot will be created for both the in-tree plugin, this may be used for the CPU memory, and for the out-of-tree plugin, which may be used for the disk I/O, for example, in this case. Yeah, but in case we have an event like the port delete, and the port delete will get the informer of the in-tree plugin for the CPU memory, it gets the port delete, so that it released the CPU memory for the port for this node without this port. But at the same time, the out-of-tree plugin, the informer, does not get the notification. So it do not remove the disk I/O information from the node. So at this point, at the time t, the scheduler, one scheduling cycle is start, it creates a snapshot. And at this time, the snapshot create time, it actually with a contest, and this contest it is to C. For CPU memory, it does not have the pod, but for disk I/O, it has a pod. So this maybe create some of the inconsistent issue. So this is what we see if we using different informer for the node pod for both in-tree and out-of-tree plugin. This may cause some inconsistent just when you create the snapshot. Yeah.
So in your implementation, did you start another informer factory rather than reuse the informer factory that is already contained in the framework handle?
Yeah. Well, I think we will create another informer. We
Why?
were using the Go client informer factory to
Why
create.
Why you create a new one instead of just reusing the one that has passed to the framework handle?
Yeah, I think in the implementation, we can get an informal factory from the framework. We just use it to create is that correct? Yeah.
I think we're using the informer from the framework. Yeah.
Okay.
Yeah.
Then, okay, I think that is back to my previous point is that if you're using the same informer factory, then you can still get the same copy, but your informer functions are invoked maybe at different times, then it causes you responded differently and hence have different cache. So that causes your function doesn't.
Yeah, what I mean is the scheduling will still work, but maybe this time is work, it will go through another scheduling cycle. Yeah.
Okay.
So but if the time is different, for example, one is T1, another is T2, but when you create the snapshot, it has a time T, and the T is between T1 and T2, so you will get a context, and this content will include the different maybe the pod information for the results for this node. So in this time, this maybe cause some inconsistent scheduling issues. I think if the node is not quite much, if
One
a small node cluster, yeah.
We have another topic in the agenda, so maybe we can park it here. I guess ultimately we have to go through the CAP to decide. Make sure in your CAP you describe the use cases as sources of information, because if I think about the case where the information is in another CR, then this doesn't fix anything. I think what you're trying to do is maybe getting some metrics, perhaps. Maybe that's one use case, or one source of information to get to gather the. You get the event handler for node create, let's say, and then you go and do a query into some metric framework. Maybe that's one of your use cases. I don't know. What I'm trying to say is, please describe what are the sources of information the out-of-tree plugin might use, so that we understand why you need this extra cache. Because if it's in another CR, then for sure this doesn't help. If it's somewhere else, maybe makes sense. So please make sure that's included in the proposal, so that we can take a more informed decision.
Okay, yeah, I think we will do that. Yeah, we will. As I mentioned, as I said before, we got the information from the metrics. Yeah.
Okay.
Real-time information.
And if you have any other sources of information, please include them as well.
Okay. In the CAP, right? Okay, we'll add clarification on that part. Yeah. So we submit a CAP. So we will submit a CAP to the SIG scheduler repository, right?
Well,
Is that the correct requirement?
the enhancements repo. I think you already opened one.
Oh, well, okay.
Yes,
So,
it's already there. Yeah.
oh, it's already there. Okay.
Yeah. Okay, so with that, we have a few minutes for the next topic. Zel Patel, are you here?
Yeah, I'm here. So
Do you need to share your screen or just talk?
no, yeah, just talk. So
Okay.
I do not have any slides as such. So what my question is, as of now, all the pre-filter plugins run serially, and at least from the default pre-filter plugins, I can see that if we run the pre-filter plugins parallelly, I don't think there will be any race condition as such. So so maybe just a question: has this path of parallelizing all the pre-filter runs been explored previously or not? If yes, why this has not been taken into account, or why this has been rejected, if it has been?
I can give a quick idea. I don't think we have tested it, but in the current implementation, I'm willing to say all of the pre-filter plugins, they do parallel calculations within. So, for example, the node resources plugin or the topology spreading plugin, they, as soon as they start, they open some parallel computations for all the nodes. And then some of them might actually have some locking to access a shared resource. So we already have, long story short, we already have parallelism at that level within each of the pre-filter plugins, and they are highly parallel. So I'm
I
not
see.
sure if parallelizing everything will overall help, or actually it might even slow down the calculations, as maybe you don't even have more cores to do more parallelism, or maybe if you do more of those, each of those routines were gonna start colliding with each other because they want to get a lock to the same thing. So worth exploring, but I doubt they will bring a benefit. Abdullah or Wei, do you have anything to add?
Yeah, I think the same way, that we only have a couple of, usually we usually just have a couple of pre-filter plugins, and not everyone goes through all the nodes, right? So some of them are just do a simple check. So I'm not sure parallel them has a more gains comparing this complexity it brings in. And also in some edge, and then also in some edge cases, if some pre-filter can fail quick, and then the further pre-filter plugins can abort. So, but if you just in parallelized runtime, you have to do another maybe cancel function to pass that cancel signal to a already running preferences running. So that is brings more complexity. I don't know. So yeah, and
Yeah.
I think unless we have a clear requirement and have clear metrics using that, it can give us performance boost. In most cases, we will adopt. Otherwise, I think we will stick to the current methods.
Okay, understood. Thanks.
Is this coming from a particular scenario? Have you run some tests or any?
No, just a general question. Not a particular scenario as such.
Okay. If you're willing to explore, by all means. But ideally, we should run the benchmarks. There are some benchmarks already in the test/integration perf. What's it called? Test/integration/scalar perf. Those might give some idea of whether the change is worth, but yeah, probably have to test in different sizes of machines.
So is the benchmark test set up in a separate repo or?
No, it's in the same repo. Test in the test folder. Test/integration/scalar perf. Yeah.
Okay, I'll check. Thanks.
Yeah, if you have some numbers that justify the change, you can consider it. But yeah.
Thanks.
With that, we're 1 minute. We have 1 minute left. We have about 3 or 4 open caps right now. We have some time until the cap freeze, so we haven't assigned reviewers yet to each of the caps. I think by the next meeting we might have maybe a more complete list of caps, and then we can do a rundown on all of them in this meeting. Yeah, any last minute questions? Right. Thank you all for joining. We'll see you in a couple of weeks.
Okay, thank you.
Bye-bye.
Bye.
Thank you. Bye-bye.